This lesson is number 5 in a series I did with the grandkids in which together we built a metal detector as they learned principles of physics that made it work. In our first 2 lessons we dealt with the physics of beat frequencies between 2 audio tone generators. The same phenomenon works when 2 radio signals are tuned close to each other. If we tune an AM radio receiver to a weak station and then turn on our radio frequency oscillator that we built in lesson 3 and tune it to that same frequency, listen to what happens. That whistle you hear is the beat frequency, the frequency of the tone that is the mathematical difference between the frequency of the radio station signal and the frequency of our oscillator. As we tune the oscillator closer to the radio station's broadcast frequency, the pitch of the beat frequency, which we hear, drops. For the next part of our experiment, we need to swap out our oscillator's radio frequency tuning coil that came with the snap circuit kit with a coil that is physically larger, like the kind that is used in metal detectors, but still has similar electromagnetic properties as the coil we originally used. Here I wound about 28 turns of enamel-coated wire around a plastic hummus tub that is about 5 inches in diameter. I removed the original coil from our oscillator circuit and in its place connect this one in parallel with the tuning capacitor. Turn the oscillator on and retune the oscillator back to the radio station frequency that we're picking up on our AM receiver until we hear a beat frequency. When I first wound the coil on the plastic tub, I intentionally added a few more turns of wire than I thought I might need, about 35 turns in all. As I tested the coil with the oscillator and the radio receiver, I unwound the coil a few turns at a time, trimmed back the wire, and tested it again until my coil exhibited properties similar to the coil that came with the snap circuit kit. Now let's bring a piece of metal near this coil and hear what happens to the tone. The pitch changes. Why does it do that? Because any metal that comes within the electromagnetic field of the coil changes the tuning properties of the coil, which changes the resonant frequency of the coil capacitor network that we learned about in lesson 3. And this change of the resonant frequency changes the frequency of the radio signal emitting from our oscillator. It's like a trombonist pulling out his slide to lengthen the tube that is his instrument, thus changing the pitch of the tone that we hear. Because our oscillator has changed frequency, the beat frequency between our oscillator and the radio station signal on the AM receiver will also change, which of course changes the pitch of the tone that we hear. If the frequency of our oscillator moves away from the frequency of the radio station transmission, the pitch we hear will rise, just like we demonstrated on our second lesson with audio tone generators. Back to our experiment with our radio frequency oscillator with a tuning coil wound around a plastic hummus tub. Here I'm using a copper tube. Let's try aluminum. So this really works with any electrically conductive metal: copper, aluminum, silver, gold, brass, and of course iron and steel. While this demonstration shows how a metal detector works, this setup is hardly practical. So we have a couple more things we need to do to free our circuit from the AM radio receiver, which we will do in our final lesson.